All right, hey everyone. I hope your night's going well. Sorry for the late post on the YouTube. But this video is going to be discussing logarithms and their properties, all right? So we're going to skip exponentials first because I feel like everyone is kind of comfortable with the exponents and their rules. So we're going to just dive deep into the logarithm functions, all right? So first, I want to go over the properties of our parent function again. All right, this is going to be very similar to what we did in class, but I'm going to slow it down and I'm going to try to help you understand a little bit better. All right, so the first thing we need to know is this equation. All right, so we're going to have y equals log base b of x. All right, that's the equation of our parent function for logarithms. All right, not too bad. We all know that we're going to have a x-intercept instead of our y-intercept. Our y-intercept's in our exponential. Our x-intercept is at 1, 0 of our logarithm. We're going to have a domain that flips from the range of our exponential. So it's going to be 0 to infinity, right? That's the range of our exponential. We have our range of a logarithm, which is the domain of an exponential since they're inverses, and that domain is negative infinity to infinity. All right, that makes sense. And then finally, we have a vertical asymptote at the y-axis. All right, these are things that we need to know. And then if we want to look at what that graph looks like, just for a reminder, all right, the graph kind of looks something similar to this. All right, where it will never touch that y-axis, and it's going to kind of flatten out towards the top here, because as our x values get bigger, the y values don't increase as much. Okay, that's all that's happening. And then we know right here at this y-intercept, that's 0.10 of our parent function, right? That's what we know. That's what we know for sure. So now that we know that about our parent function, we can talk about the product rule of a logarithm. The product rule of a logarithm. And what the product rule of a logarithm states is that if you have log base b of m times n, ooh, sorry, got hair on me. We can then split that up. We can then split that logarithm up. We keep the same base, we keep the same logarithm base, and all we do is separate that m and add it to that n. Okay, that's all we're doing here. In this product rule, all we're doing, let's say we have log base, let's say we have a common log, all right? A common log is log base 10, all right? That's what a common log is. I'll even write that down for you. Common log. All right? Here, let's see if you can see that. There. Log base 10 is the common log, all right? If you have log base 10 of x times y, right? X times y, we can then break that up into log base 10 of x plus log base 10 of y. And that's all we're doing with the product rule. So all you have to recognize is that there's multiplication going on inside our parentheses. And if there's multiplication going on inside our parentheses, we can break that up into two separate parts, an x and a y. We keep the same log and we just separate. We just expand the two. That's all we're doing. All right. This rule, this product rule, is really similar to one of our exponent rules, right? If we had b to the m power times b to the n power, we can combine that by saying b to the m plus n, right? You agree with this? If we have b to the m power times b to the n power, multiplication with the same base, we then add the two exponents. We have multiplication with the same base, we just add the two variables. That's all we're doing. Multiplication with the same base and an exponent, we add the two exponents. Multiplication with the same log base, we just add the two variables, separating them with two separate logs. And if we were to have three things, let's say we have three things being multiplied. We'll keep with the log base 10. Let's say we have 2 times x times y. We can then, all we have to do is just break it up into three separate parts now. Log base 10 of 2 plus log base 10 of x plus log base 10 of y. All we did is we took our multiplication and separated out with addition. It's the same thing as doing this. All right, that's all we're doing with the product rule. Let's look at the quotient. All right, the quotient rule. With the quotient rule, let me make sure you guys can read this. All right, with the quotient rule, all we're looking at is when we have log base b of m divided by n. Ooh, forgot to do this in different colors, so I'll just underline in blue, underline in green. Okay, so you know. That's an n. This is an m. All right, let me make this a little clearer for you. This is an n. All right. We can then break that up to log base b. So we keep the same log base. Again, the log does not change anything. We keep the same log base. We have of m. So our numerator first minus log base b, the same base, of n minus our denominator. We have our numerator minus our denominator. Log base b of m minus log base b of n. All right? And what this says, our quotient rule, is very similar to our exponent rule, right? We have b to the m divided by b to the n. We can then break that up into b to the m minus n, right? We have division of exponents with the same base. We subtract the exponents. We have a log with division inside. We keep the same base and we subtract the variables. Same thing. It's the same concept. Right? That's all we're doing. And with numbers, if we want to look at it with numbers, we can do this. Log base 10 we'll do again, right? The common log. We can do 3 divided by 2. All right? 3 is the numerator. It's in blue. 2 is the denominator. That's in green. All we're doing here is just separating log base 10 of 3 minus log base 10 of 2. And now, let's try to combine. Oh, sorry, you can't see that. All I did was log base 10 of 3 minus log base 10 of 2. We have 3 divided by 2, our numerator subtracted by our denominator. We keep the same base of our log, and that's it. All right? That's all we're doing with the quotient rule. Now, it could get a little tricky. On one of the practice problems, we had ln, right? We had ln x to the third power we're going to do something different. We'll do x to the y, x times y over 2. All right, and I wrote in different colors so you can see that. I did in different colors so you guys can see what I do. The first thing I'm going to do is the quotient rule. I'm going to do the quotient rule first. I'm going to separate the numerator from the denominator, okay? I'm going to separate the numerator from the denominator. So we keep that ln. We're going to have right in here x times y still. Minus ln, because we keep the same log, we keep the same base, of 2. Natural log of 2. Okay? That's all we did on our first step. We just did the quotient rule. Our numerator minus our denominator. Our numerator minus our denominator. Now we can break it up one more time. All right? We can break it up one more time. Because we still have the product rule here. All right? We have two things being multiplied in a log, so we can expand that a little bit further. Our product rule states we're going to have ln of x plus ln of y minus ln of 2. And now this is where the tricky part comes in, all right? So the tricky part comes in. When we divide something, right? When we're dividing, it matters about our order. Our order matters. So yes, if we were to move left to right here, we would do our numerator first and then we would do our denominator. But just to ensure that no one messes up, we're going to put brackets around our numerator. We're going to put brackets around our numerator. So that way, if we give this problem to a random person, there's no way that they're going to do ln y minus ln 2 first, because the brackets ensure that they do ln x plus ln y and then minus ln 2. Because in our original problem, we would have to do x times y first and then divide by 2. I hope that makes sense. All right? So that's what it looks like when you combine the product rule and the quotient rule. All right? Those are the two rules combined. We still have one more to cover. Let's talk about the power rule. Let's talk about the power rule. In the power rule, what it states is if you have log base b of m to the p power, right, where m is blue and p is green, we can separate that where we take our exponent, we take the exponent and we shift it all the way to the front. That's all we're doing. We take the exponent and we're putting it right into the front. So that p goes to the front of the log and it'll be multiplied log base b, and the m stays where it was. The m just stays. You get rid of the exponent and the m stays, all right? So let's make sure you guys can see that. Perfect. All right, all that's happening is we take our exponent, we're moving it to the front. So we have p times log base b of m, all right? And when what that would look like with numbers is I'm going to do the common log 10. We're going to have, let's do x cubed, or again, x is blue and 3 is green. When we expand this, we would take our 3 and put it into the front of the equation, right? Just like what the rule says. And we're going to end up with 3 times log base 10, our base stays the same, we never change that, of x. We drop the exponent and we just write what was in the parentheses, x. 3 log base 10 of x. These are equal to each other. All right, now we're going to get a little bit complicated. We're going to try 3 different examples. All right, we did one with just the power rule. We're going to do one that includes the power rule and the product rule. We're going to do one with the power rule and the quotient rule. And then we're going to do all 3 together. All right, so the first one we're doing is the power rule and the product rule. All right, the power rule and the product rule. So let's do log base 8. This is part of the classwork that we did of x to the 4th power times y to the 7th power. Okay, let's fix the camera a little bit. All we're doing first is separating them according to the product rule. All right, the way I personally like to do these rules in order, I'll write it over here for you, is first I will do the quotient if there is one. There's a quotient rule, I'm going to do that one first. All right, then I'm looking for the product rule. All right, then I'm looking for the product rule. If I don't have a quotient rule or a product rule, then I'm looking for the last one, the power rule. All right, and this isn't set in stone, but this is what I like to do personally because it helps me, one, separate the numerator from the denominator first, if there is one. Then it helps me separate all of my terms. And then I can worry about my exponents because exponents are dedicated to their term, right? They don't change. What I mean by that, this x to the 4th power, this 4 is going to be with x forever. It's not going to go to the 7. All right, that's what I mean. So let's get back to this. We have the product rule. According to what I said, I look for the quotient rule. We don't have one. Now I look for the product rule, and we have x times y. So according to the product rule, we keep the same base. We have x to the 4th power. Sorry, my purple doesn't work too well. X to the 4th power plus log base 8. The bases don't change again. Of y to the 7th power. All right, we separated our 2 terms. We have 2 separate logs now. Now I can do the power rule, right? Because we don't have a quotient, we don't have a product, we only have our powers. So I'm going to take this exponent here, this 4, I'm going to move it to the front of this log. I'm going to take this 7 here, I'm going to move it to the front of this log. All right, so at the end of the day, this will become this will become that 4 to the front. All right, so we have the purple 4. Ooh, bear with me, pretend it's purple. All right, I'm going to use the black for now. Pretend that's purple. Log base 8. We keep our variable in the parenthesis. So 4 times log base 8 of x, we have our plus, right? The product rule, we keep it the same. And then we take our 7, move it to the front, log base 8 of y. And that's how you expand, right? That's how you expand. And eventually we're going to get into condensing, right? So you would be given this here, and you would have to move it back to this step, and then back to this step, okay? It's just moving in reverse. Condensing is moving in reverse. We have this, we're given an expanded equation, and we have to make it smaller. And expanding is getting this equation and moving down the chain to our expanded equation. Okay? Same process. We're still on an expansion. Going to look quotient, then product, then power. And if we're doing it in reverse, we're going to do this in reverse. We're looking for power, then product, then quotient. All right? That's how I personally like how to do it. You don't have to do it that way, but I think that's what makes the most sense when working out. All right? Let's do 2 more problems. That was the power rule and the product rule combined. Now we're going to do the power rule and the quotient rule combined. All right? Cool. We have ln of x. Hopefully this purple works. This purple sucks. X cubed over y to the second. I don't have purple, so I'm going to make it black. Sorry, there's no color differential there. That's the best I can do. That purple's not working. All right, so you have natural log of x cubed divided by y squared. All right, first, what's my first thing if we're expanding? The quotient rule. We have the quotient rule, so I'm going to separate the numerator from the denominator. We keep the same log, so we have natural log of x cubed minus our denominator, so the natural log of y squared, right? And now, since we moved on to here, we only have the power rule. We're going to take this 3, move it to the front, and take this 2 and move it to the front. All right, that's all we're doing. We're going to end up with 3 ln of x minus 2, because we moved that 2 to the front, ln of y. All right, that's all we did. That's all we did. And this would be our final answer. Eventually, you'll be given something that looks like this, and you'll be asked to condense and move backwards. So you'll notice that we'll move our exponents there first, right? So we'll end up with this step. And then we notice that it's subtracting, so we know our numerator is going to be the one on the left, and our denominator is going to be the one on the right. All right? Now let's combine all the rules I just told you, all 3 that I just told you. Let's try one. Log 10 of x, I'm going to do this all in blue, x cubed times y squared all over, I'll do this in green, z to the 4th. Z to the 4th. All right, I'm all the way down here, by the way. This is the best angle I can give you. All right, log base 10 x cubed times y squared over z to the 4th. First thing we do, if we look back at my rules, the quotient rules first when we expand. So I do my numerator minus my denominator. My numerator, log base 10 of x cubed times y squared minus log base 10 of z to the 4th. Now we look back at the rules, and we're going to be doing the quotient rule, then the product rule. Do we have the product rule? Yeah, we do. X cubed times y squared. So we're going to make that into log base 10 of x cubed plus log base 10 of y squared minus still log base 10 of z to the fourth. All right, that's what we're going to have, this right here. We have one more step, and that step is going to be the power rule, right? Because we have powers on all of our things. But first, what we did at the top, what we did over here, where is it? What we did over here, when we had our product rule and our quotient rule, we did the quotient rule first. We separated the numerator and the denominator. Sorry, let me try to get this evened out. We separated our numerator and the denominator. Then we did our product rule to the numerator and put our brackets around them. We're going to need to put those brackets there again, all right, on our numerator. So our numerator was x cubed times y squared. So we know on the product rule, we're going to have our brackets around x cubed and y squared, all right? All right, there's just one thing I want to add. So when you do the brackets, all right, when you're doing these brackets, I know we did the brackets only on the numerator in the two problems that we did for as examples in this video, but the brackets also apply to the denominator. If you have the product rule going on in the denominator, you need to put the brackets around the denominator so they know to do that first. So for example, if this was z to the fourth over x cubed times y squared, the brackets would still be around x cubed and y squared, but it would be on the other side of the equation where z to the fourth is on the left and x cubed to y squared is on the right. It's going to be a little confusing without seeing it. If you need help, I can go over it before the quiz tomorrow, but I'll try my best not to give you guys any of the product rule and quotient rule combined with the denominator being affected. It would look more like the video. We're going to have our brackets around x cubed and y squared. I know this looks messy. I know this looks hard, but we're not doing anything too difficult. All we're doing is when we're multiplying, we add them. X cubed times y squared becomes x cubed plus y squared. And if we're dividing, we're subtracting x cubed plus y squared minus z to the fourth. And then after that, we take our exponents and move them to the front. Exponents have priority. They are powerful. You bring them to the power of blank. They're almighty powerful, so they go to the front of the line. You take your exponent because they're so powerful. You put it in front of your log because they are first. They are first. And we do that for each term. For each term. So what that ends up being, give me a second, I need a new paper. And we're going to take our 3 here. I move it to the front because, again, exponents are almighty. They're all powerful. They belong first. And they belong in the front of the line. So they'll get that. We're moving all of our exponents in front, into the front. So we end up here with 3 times log of x plus 2 of 2 times the common log of y don't forget the brackets, right? We just drop the brackets down, minus 4 times the common log of z. That's all we do. That's all we're doing. It seems like that was a lot, but I promise you if you take it step by step, it's not too bad. It's really not too bad. I don't want you to get tripped up on the logs. I don't want to get tripped up on seeing a log and getting flustered. All this is doing you can even ignore it if you want to. You don't even have to look at the log. You just remember to include it in your final answer. The logs don't mean anything in these rules. They're just there because they're the inverse of an exponent. It's a function. That's it. You're not doing anything different than you've done before. You just are learning a little bit more rules. The product rule, if you see a product, you add them together. If you see a quotient, you subtract the numerator from the denominator. And if you see an exponent, exponents are almighty, they're all powerful because you put them to the power of blank and they deserve to be in the front of the equation, so they will be. That's why we have our coefficients here. All right? That's all that's happening. What the common log are and the natural log are. All right? I don't want you guys to think too much into this. All it is notation. It's just different notation. Okay? The common log, the only reason why it's called the common log is because this is the log that is used the most. This is the log that's used the most often. All right? And that log is log base 10. Log base 10 is the most common log possible. And it could be rewritten as just log of x. So the only thing you have to remember from a common log is if you have a logarithm with no base, it's log base 10. If it doesn't explicitly state the base of the log, it's automatically assumed it's base 10. All right? The common log means base 10. And then the natural log, you don't have to know what e is because there's a button on your calculator for it. It is just log base e. All right, that's all it's saying. If you see a natural log, it's just saying the base of it is e. It's just a different way to write it. Different notation is ln. You have an n, it means it's natural. And if it's natural, you have an e. All right? E is known as Euler's number or the natural number. And a lot of you guys ask me, where did E come from / what is E or why do we need E? But that's like asking me, what is pi? Why do we need pi? And why do we use pi? It's because pi is useful. It's a number that we need to solve equations. E is the same thing. Think of E as pi, all right? It's a variable that represents a number. And that number is about 2.7. Yeah, 2.718. Around 2.718. You don't have to remember this. But if it really bugs you, right? Because we all know pi is 3.14. If it really bugs you, you can think about E as a number of 2.718. All right? And that's it. The common log is base 10. The natural log is base E. And E is just a letter that represents a specific number that is the natural number. That natural number is just 2.718. The same exact concept as pi. It's just a different number than pi, all right? And like, we just need to know if you have log base b, so any base of the log, of 1, it equals 0. And that makes sense, right? Because our parent function, our parent function looks like this. Log base b of x equals y, right? And we know, according to our table right here, we know there's an x-intercept when x equals 1, y equals 0. When x equals 1, y equals 0. Same concept. Another way to think about that is if you were to move it into exponential form, right? Our b becomes our base. Our y becomes our exponent, and our x becomes our answer. And we all know b to the 0 power will give you 1. So if this confuses you, you can switch it to exponential form and it will make sense. And that goes for most of the beginning rules, right? That goes for most of the rules that we learned in the very beginning, 1 through 4. 1 through 4, you can justify by thinking about it as an exponent, right? So I'll go through 1 through 4. This was 1, all right? This one's 2. Sorry, the numbers are so small. This one's 2. We have log base of b equals 1. So we have, again, our base b as the base of our exponent. We have our y value as our exponent. And we have our x as our answer. B to the first equals b. You agree with that? I agree with that. That makes sense to me. I know what this looks like. I know this rule. So if I know this rule, I should know this rule too. As long as I'm able to convert, which we all should be able to convert, where the base stays the base, the y becomes the x, and the x becomes the y. This makes sense. We'll try number 3. Number 3, we have log base b of b to the x equals b to the x. I'm sorry, not b to the x. It equals x. It equals x. My fault. That might have been confusing. Log base b of b to the x equals x. Why is that? Let's try to put it in exponential form. We have our base b. Base b. We have our y value in our logarithm. That becomes our exponent. Right? B to the x. And then our x value, b to the x, becomes our answer. B to the x. So all this is saying is when our base and our x value is the same, they cancel out and you're left with just x. If our base and our x value are the same, they cancel out and you're left with just your exponent as the answer. Okay? Base b to the x power is equal to b to the x. That's all that's saying. And number 4, our last one, this is the one that tripped everybody up. So I'm going to write it a little bit further down. All right? So we're right here. All right? We're going to have number 4. We'll have b to the power of log base b of x equals x. All right, let me focus this up a little bit better. And this makes sense because I just told you when our bases are the same, they can cancel. So that log cancels out, that b cancels out, and we're left with afterwards just our x value. X equals x. That's it. All right? And if we really want to go into this, it's going to get a little messy here. All right? So if you want to skip over this part, you're more than welcome to. But all I'm going to do is change it from logarithm form to exponential form. Base b to the x. You have base b to the x. Then we have it equals our bottom here, because this is to the power of this. So we have to include this bottom as what part of our answer. And then this here is also part of our answer because the x value turns into our y. So again, that might have been a little confusing, but in all you're doing here is canceling out the base of the exponent with the base of the log. The base of the exponent and the base of the log are the same. They cancel out. All right? Now this is the rule that's going to help you probably the most with solving things algebraically. But we don't have to worry about that until next week or Friday. Don't worry about that for the quiz. Just understand that when you have the same base of your exponent as the same base of your log, they cancel out. If you have, trying to find out where the camera is. There it is. Same thing here. You have the same base of your exponent with the same x value, right? Because this is technically x. If we look at our parent function, that's x. That b is replacing the x, right? Our base times this value cancels out. We're left with just the exponent. All right, that's all you're doing. It's not too bad. I believe in us. Quiz tomorrow. Email me if you have any questions. Sorry this came out so late. And yeah, good luck tomorrow on the quiz. It will be short. It will be easy. Should be an easy grade. And you guys got this. Talk to you tomorrow.